Welcome. The purpose of this video is to go through the extra practice problems for the Hess's law. This was linked in one of your homework assignments, and someone asked me to walk through number 4. So I have an overall reaction, I have some intermediate, so that's telling me Hess's law. I need to find a way to get delta H theoretically because for whatever reason, maybe I want to compare it to the experimental version. Maybe the experimental version does not work with this particular equation, so I need a theoretical way to come up with enthalpy changes. And in this case, we're just using multiple intermediates and applying Hess's law. All right, so I'm going to start by just figuring out where in my intermediates are parts of the overall reaction. So P410, where do I see P410? Right there, that's the only place. Okay. PCl5 shows up here. Awesome. Cl3PO. Cl3PO shows up right here. And I think that is everything. Let's just double check. P410. Cool, PCl5, I don't see it anywhere else. Cl3PO, whoops, I did not mean to erase that. Okay. All right, so you notice we have a whole intermediate here that doesn't even have one of the reactants or products. That tells me that it's somehow going to be needed to cancel out some of my other intermediates. In this case, my intermediates are Pl3, oxygen, and chlorine. It looks like this reaction has all three of those. So I'm going to start with my first reactant. I notice it's in the products of my intermediate. I need it to be in the reactants at the end. It has the correct coefficient already, so I don't need to multiply by anything. So all I'm going to do is switch this reaction. P4O10 yields 5 oxygens plus P4. I like to just take out the state symbols here because I find it easier. You can keep them in if you want, but I just like it to look nice and simple for me. I'm going to have the same quantity. I didn't need to multiply anything, but I do need to switch the sides. All right, cool. I'm just going to cross this out because I've used this one, and I want to keep things straight. PCl5, awesome. I'm going to figure out how to get PCl5 in my overall reaction. I see I have 6 of them here and 1 of them here. That means I'm going to have to multiply by 6. I also see PCl5 is in the products and it needs to end up in my reactants, so I'm going to need to do a little switching. So I'm going to end up with 6 PCl5. Perfect. Yields 6 PCl3 plus 6 Cl2, and then delta H is equal to 6. I need to flip the sign. 84.2 kilojoules. All right, cross this out because I've already used it. I want to keep things neat. Down here on the bottom, I see that Cl3PO is in the correct spot, so that looks good. I'm going to multiply everything by 10 because I need to get this coefficient. I don't need to flip any signs though. So PCl3, let me write it. I'm going to write it so that there's space. PCl3 plus 1/2 oxygen yields Cl3PO. Delta H, of course, is negative 285.7 times 10. I need to make sure I'm including that times 10. 5. Okay. 10. Sorry. I'll go over that again in just a moment. 10 Cl3PO. Okay, so I multiplied by 10 in order to get that coefficient I wanted. So now 10, 1/2 times 10 is 5, 10, and I multiply my enthalpy change. No flipped signs, this went in the same direction. All right, so Now I see, I'm just going to highlight in, oops, let's choose another color here. Let's do pink. I'm going to highlight in pink everything that needs to end up in my overall reaction. P4O10, 6PL5, great, 10Cl3. And now let's look at how things are starting to cancel. I have 5O2s, 5O2s, okay. P4 doesn't yet have anything to cancel with. So I see some P4 in that extra equation. That's looking good. 6PL3s and 10PL3s. So 6 of these cancel, but I have 4PCl3s, excuse me, that haven't canceled yet. Okay, so I'm going to need some on the other side. Cool. And then 6Cl2, those have not canceled with anything. So let's just try dealing with one of these and see how things kind of shake themselves out here. So I need chlorine to cancel. Right now I have 6 chlorines on the right and none on the left. So if I want this 3 halves Cl2 to give me 6 Cl2 so that it'll cancel, what would I need to multiply my 3 halves by? I'll give you a moment to think about that. If I multiply this, what would I need to multiply by so that I get 6? Well, what if I multiply by 4? Then I get 4 times 3 over 2, which equals 12 over 2, which equals 6. Multiplying by 4 is looking good. What about P4? I have 1 P4. I currently have a fourth. All right. It's feeling like I'm going to need to multiply this by 4. So let's try it. 4 times 1/4 P4 is just P4. Great. 4 times 3 halves Cl2, I just proved to myself, is 6 Cl2, yields 4 PCl3. All right. I'm feeling good about my canceling. Let's take a look. 5 oxygens, canceled. 6Cl2, 6Cl2, canceled. Oh, I'm sorry, I did not write the enthalpy change. Delta H equals 4. I kept the sign the same, so negative 306.4 kilojoules. Okay, let's make sure everything is canceled in the way that I expect. Let's keep going with that. So P4, P4, that's now canceling. And I have 6 plus 4, PCl3, so that's 10. And 10 here, great. And so now my overall reaction is P4O10 plus 6 PCl5 yields 10 Cl3PO. And I just need to add all of these up to get my overall delta H. And I've already given you the answer here. All right, I hope that helped. As always, let me know what questions you have, and have a good day.